I typed one sentence into Claude Code and my AI agent sent me this. It's powered by Nano 2, Google's latest image generation model, but it's not this good out of the box. Here is another image that I generated directly with Gemini, and you can see a clear difference, not only in the colors that are used, but also in the layout and the legibility of the diagram overall. So in this video, I'm going to be breaking down the secret sauce that gets you from generating images that look like this to diagrams that look like this on the right here. I've been obsessed with Claude Code lately, and I've been sharing everything I'm doing on this YouTube channel. I build all of these as Claude Code skills, so you could literally take the transcript to this video, paste it to your Claude Code, and have it recreate the same exact thing, or you can head to my community, AI Innovators, and you can download them in one click. Either way, I want you guys to get a ton of value out of this video, so let's jump into a diagram breaking down how this system works. So we have an 8-step pipeline here. I'm going to walk through each step, but I also want to note that each diagram I'm going to be using to explain this process was also generated with the process itself. If you find these diagrams helpful or useful, I didn't make them by hand, and I'm showing you exactly how they were made. Let's slow down for a minute and let's just take a look at the overall pipeline, how everything gets generated. You can see that phase 1 happens within Claude Code. So we make a request, Claude starts building an SVG blueprint. Now you could think of an SVG like image as code. You can write some code in a file and it will automatically display that image based on what was written. But the really interesting part is that AI can actually read these diagrams. So we generate the SVG and then we have Claude Code go through and critique the SVG. We want to make sure that nothing's overlapping, that all of the text is legible, that the arrows point to the right things. And once that critiquing has been completed, we use a Python script to actually generate the diagram. Now this Python script has a variety of different jobs that it accomplishes. It's going to parse placeholders. So when we generate this SVG, it's going to include placeholders for images that we might grab from the internet and include in our diagram. For example, in this diagram right here, you can see that the Gemini logo was passed directly into the model as a reference image. So it went through this entire process right here. There was a placeholder for the image. It searched the web using Tavily and it found this image. It downloaded the image and then it assembled the prompt and generated the entire diagram using Nano 2. Finally, it outputs a PNG image that looks like this, and you can go back and forth with Claude, making any changes you need. So I'm not going to go too far in depth explaining each of these sections. I do want to get into some examples, but I'm going to run through each of these steps so you know from a high level what's going on. Now, when we generate these SVGs, there's a variety of things that go into that. That includes the specific size for the SVG, and it also includes a couple different common layout patterns that we often see used in this type of diagram. The critique subagent has an incredibly important job, and you can see some examples right here. So box A overlapping box B, the critique agent is going to find that and reprompt itself until it gets it right. So our diagram should never move on past the critiquing subagent until the SVG is 100% perfect and ready to be generated. And once we're sure we don't have any of these major issues, we can move on to the generation script. There are a couple different flags within this Claude Code skill. We can generate directly as an SVG. We can add a prompt if we want, or we can output to a specific file. We can also choose to generate with no images whatsoever, so it won't use Tavily to find Google Images. We can set specific aspect ratios, and we can also set specific reference folders. The Python script will parse those image placeholders. It'll search for images using Tavily, download those images, and then construct the entire prompt to generate the diagram. This is a good time to mention that you will need a Gemini API key in order to generate these diagrams. And if you wanted to pull reference images from Google and include those in the diagrams, you'll need to populate your Tavily API key. So here you can see an example of what an SVG blueprint might look like, and you can see some examples of placeholder images here. We're going to use a regex parser to pull those out, extract the queries, and then search Tavily for those images, get the images, and then we can include them as references in our prompt. And finally, we're going to use our prompting framework that we've dialed in over the last few months of using Nano Pro to pull everything together into one prompt and generate this image for us. So that being said, the visual style of these diagrams is completely customizable, and the skill actually comes with 2 visual styles right out of the box. So we have this color format that I've been using throughout this entire video, and then we also have a mono format. Now the mono format can have a black background with white text or a white background with black text, and Claude will either decide what's going to look best or ask you for your preference. I also do want to know if you're posting these as social media content on LinkedIn, on Instagram, wherever you're posting it, you can also add your credits at the bottom of the diagrams. So in order to get this skill to work, we have a variety of different Python scripts that are involved in the process. We have generate.py generate.py, which is going to generate entire diagrams. We have generate illustration.py, which is going to generate single visuals, so maybe one component of those diagrams. And then we have generate hand-drawn slide, which will actually take these diagrams and generate a variety of carousel slides to be used on LinkedIn or other social platforms. So I'm just going to open up VS Code and I'm going to say /diagram, Gemini diagram, how Perplexity computer works. We'll give this a second. We'll walk through everything that it does to get to our final output, and then we'll take a look at the results. All right, so it just wrapped up the generation, and I want to take you guys through the process it went through to actually get these results. So we can see the first thing it did was create the SVG. Then it ran the SVG critique subagent, and it actually found some issues. So it needed to fix the squiggly underline to be the full title width and be centered, fix an arrow, fix the LinkedIn text, as well as improve the label to content proximity for steps 3 and 4. It went through, it made all of those changes, and it outputted our PNG to this file right here. If we just open up this file, we can take a look at the diagram that was generated. Now we can see that it is in the same style and color format that I've been using in my previous diagrams, but obviously this is customizable if you'd like. Overall, this diagram is very legible. Everything makes sense to me and it's pretty easy to read. The credits came out perfect, and I like this little sticky note that kind of brings everything all together. So that's the entire system. If you took one thing away from this video, let it be that there are sometimes better ways to prompt than with text alone. And if you got any value out of this video whatsoever and you want to learn more about building systems like this, please subscribe to the channel, leave a like on this video. It helps me keep making videos like this, and I'll see you in the next one.